Bismillah ar-Rahman ar-Rahim. So the other day we started talking about what we called or what we call solid class design principles. And as I said the other day, each letter of the word solid stands for one of the principles. We covered the other day something called single responsibility principle. And the whole idea behind single responsibility principle was what? If someone recalls that one. What was the fundamental concept behind single responsibility principle? Anybody?
That each class must have only one responsibility.
Yeah, so each class should have only one responsibility, which means, if you recall that book example, then, if you have a set of getters and setters, so one kind of reason for changing it, and you have another kind of reason for changing it, it's recommended that, I'm going to call it RC, reason to change. So if there are multiple reasons to change, it's recommended that you split them into different classes. So in other words, one class should only have one reason to change. So this is the first principle of the solid principles of coming up with a good class design. The other one was the open close principle. What was that one?
Open for extension and closed for changing or modifying.
Exactly. So if I have the same class and of course I can change them or extend them with the help of inheritance or interfaces. So for example, in whatever the case is, if I'm going to make a change, I should go on and make a change by creating a new child class or come up with an inheritance relationship or interfaces, but I should not be changing the original class, right? So these were the two principles we covered the other day. Now we're going to focus on something called Liskov's substitution principle today, and then we're gonna talk about the interface segregation principle, and probably I'll stop it here today just to be sure that both sections are in synchronization, and then we'll talk about the dependency inversion principle inshallah on Thursday. Now, for the Liskov substitution principle, it's not that hard. By the way, all these five are not hard, but they are just, needs us to think differently and come up with, basic understanding of how we can come up with a good class diagram. So I'd like your special attention especially for Liskov substitution principle, because it's slightly, over the years, I've noticed that sometimes we struggle to understand that one. It's not hard at all, but let's dig into it, right? So I like your special attention for this, especially the Liskov substitution principle. What the principle says, it says that an object of a superclass should be replaceable by objects of a subclass without causing any issues in the application. So and of course, as you can see, this is all about the inheritance relationship. So this principle focuses on inheritance relationship, and it says that an object of a superclass can be replaced by an object of its subclasses, and it should not break the application. If I have put another word, in other words, I will say a child class should never change the characteristics of its parent class. So it should not go on and change. So if I have an inheritance relationship happening here between classes, then the child classes should not go on and change the characteristics of its parent class, especially, in terms of its methods, argument list, and return types, and so on and so forth. Right? Now, let me go through it and explain it with the help of an example as we move along, and then we can have, inshallah, a good discussion on what our understanding is. So, as I just said, Liskov substitution principle is focusing on coming up with correct inheritance hierarchy. So this one is specifically designed for helping us come up with correct inheritance hierarchy in an object-oriented system. Let's take that example of the bookstore again, right? Remember we had a bookstore application which we used to explain the open segregation, the single responsibility principle and open close principle. So we're going to take the same example, and now we are saying that this bookstore has a delivery mechanism, right? Now, uh, by the way, I'm going to go through now this example and kind of explain its different implementation, different functionalities, and add implementations into it, and then we'll talk about whether it's violating or not violating the Liskov substitution principle. So this bookstore has a book delivery mechanism, and we should be able to go and get locations of different deliveries where the order can be delivered. So I, as being one of the designers, I just went on and did this and wrote this piece of code. So I have a book delivery class, and it has a certain delivery location. No problems whatsoever here. Now, as we move along, uh, the store tells us that, or maybe this is the next requirement or whatever, it tells us that, they have these fancy hardcovers for their books. And these ones, because they are fancy, they want it to be only delivered to certain high street shops, right? So they are not going to be delivered to everyone. They're going to be delivered to certain special shops. Okay. So basically, what we do is, okay, so you want some special delivery now. So I said, okay, I have a book delivery class already with me. And I have this get delivery method here with me. Get location method with me now. You want a hardcover delivery, and that's going to be delivered to certain special locations. So I said, okay, no problems. I'll do this. I'll just go on and inherit it. And I will come up with something called hardcover delivery, book delivery class, and I will go on and override this get location. Now, why I'm overriding it here?
Because the parent class have this method.
Yes.
So I override it so that there is no confusion.
Or in other words, because the reason I'm overriding is because I need to, somehow, when I'm getting the delivery locations, I only want to give the high street shops delivery locations, correct?
Yes.
Yes. So I need to modify this, and of course, because I'm using inheritance, and it makes sense from that perspective that hardcover delivery is a special kind of a book delivery. So I'll inherit it, and since there's a get delivery location method available in the book delivery, but this one is different because I need to only ship it to high street shops, I will override it. Nothing wrong in it so far, right?
Doctor,
Now, yes, please.
why don't we have something like a delivery location class, and then we have like a child called the high street delivery location, and then we don't have to create this hardcore delivery
Class.
which extends book delivery. Yes, we can use the same get delivery locations method. Or is
Good
it
one.
not correct?
No, it's a good observation. What I would like you to do is just hold on to this suggestion you have, right? And maybe in a few minutes we'll talk about it, right?
Okay, sure.
Okay, so it's a valid solution. It's actually a valid suggestion, but let's see, because I'm deliberately coming up with a solution here just to highlight what's an issue with the Liskov substitution principle, all right? Or how we actually tend to violate this principle very commonly. So I said, okay, hardcover delivery, I'll just go in and extend it, and I will override it, no problem whatsoever. But later on, we see that, this bookstore has, an audiobooks now as well. So we need to deliver these audiobooks as well. Well, I'll say, okay, no problems. I already have this book delivery class. And I have this, fancy hardcover ones already with me. All I have to do is basically go on and add a audio delivery. Now, what's the potential issue when I'm doing this from a delivery perspective?
Maybe you have electronic audiobooks.
Exactly, electronic audiobooks. So there's no such thing as physical location. So, I go on and I said, okay, since I have a book delivery class already with me, so I'm gonna just go and create an audio delivery subclass. I can do that, but the problem is these audiobooks are not delivered to physical locations, right? So I don't have any physical location delivery. In other words, because I'm inheriting, so I have to still override it, but it will have no implementation. It will be like, it will be meaningless in a sense to have a get delivery location in this case. Now, my question is, am I now violating the Liskov's substitution principle? And if I am, why I'm violating the Liskov substitution principle?
I think yes, you are violating it because the principle said that the child does not change the behavior or the features of the parent.
Exactly. Everybody on board with us on this point? This is something we do a lot, and we tend to do this a lot. But as I said, it will compile. It will have no implementation. It will still compile. But it is actually breaking the Liskov substitution principle because, as we said in the Liskov substitution principle, a child class should never change the characteristics of the parent class. And this way, we are changing the characteristics of the parent class because the get delivery location has a specific meaning in the book delivery. Now, when I inherited this one here, did I violate the Liskov substitution principle?
I think yes.
No, I don't think.
So why not?
Because it didn't change the features.
Yeah, we didn't change the characteristics of the get delivery location. In other words, I'm not saying, or Liskov substitution principle does not say that don't override. This is the point I'm trying to highlight here, okay? Because we have four fundamental points or the four fundamental concepts of object-oriented design, right? Which we covered in the beginning of the semester: abstraction, encapsulation, inheritance, and polymorphism. So Liskov substitution principle does not say that don't override, because otherwise, what's the point of having overriding or polymorphism in an object-oriented system? No, it's saying to us, don't change the characteristics of the parent classes, right? Now, the get location in this example is not changing the characteristics because it's still getting us a delivery locations, which is what the book delivery method is doing, right? Which is what the book delivery method is doing. But in this case, because there is no such thing as audiobook delivery, so basically, if I will implement it, either I will implement nothing in it, or I will implement software download functionality, which is actually not get delivery location in a sense. So, we will be forced to change the characteristics of the get to delivery location, and of course, it violates the Liskov substitution principle, because Liskov substitution principle says a child class should never change the characteristics of the parent class. So we cannot, replace the book delivery with an audio delivery. And in other words, if we go back here, it says the principle says that an object of a superclass should be replaceable by an object of the subclass without causing any issues in the application. Now, in this case, for the audio book delivery, we can't do that because it's the get location, the book get delivery location is completely different. It's not the one which the book delivery superclass is intended for.
Doctor,
Yes.
yes. So could we change the visibility of the method in the audio delivery? Yes.
So basically,
so yeah, to make it private and make another function that
make another function, right? Make it
that
private.
yes.
Okay, I'll comment on this one as well, right? It's another important observation here. Just remind me when I'm slightly done with this part, okay? We'll comment on all of this, inshallah, in one go. Okay, so basically, let's look at the solution first. So basically, what we can do is we need to fix this inheritance problem we have created here for us. We can do that by introducing another extra layer of, to help us differentiate between different book delivery types. So we have, in our system now, an offline delivery mechanism and an online delivery mechanism, and we can easily split this into these two separate delivery mechanisms. And then we can have this get delivery location moved to the offline ones, and then we can create a new one called software download options for the online one. And basically something like this. So we can have a class called book delivery. It has these basic parameters in it, and then we have this offline delivery, which is extending the book delivery, and it has its own get delivery locations, while we have something called online delivery, which has its own specific functionality for get software options. And once we have refactored our code, what we can do is this hardcover delivery will be child of the offline, while of course it will still go on and override it, and it is still acceptable because these get delivery locations for offline and hardcover are of the same type. So we're not doing apples and oranges here. They're exactly the same thing. But we can also override it because Liskov substitution principle does not stop us from overriding or doing the polymorphism. It just says that don't change the characteristics. While on the other hand, the audio book, because it's an online delivery mechanism, so we'll make it a child of the online delivery mechanism, and hence, because it's now part of the online delivery mechanism, we don't really have to worry about this method anymore because it's not there in our online delivery. And as a result, we can just go on and implement our get software options with its own implementation, something like this. So basically hardcover now will go on and extend the offline, and the audio delivery will now go on and extend the online delivery mechanisms. They have their own methods. Specifically, they are not changing the hierarchical rules, or they're not breaking the hierarchical rules that you should be able to replace the parent class object with a child class object, which is still working fine, absolutely. And basically, we have kind of removed, issues of the Liskov substitution. In a nutshell, this is what we have. This was our original design, or the first design, and now we have our second, or what we call a good design, which follows the Liskov substitution principle. Now the floor is open for questions, and let's take all these questions one by one. The first one was can you remind me what was the first observation you made?
That's my friend.
The method one, right?
No, there is one observation before me.
Yeah, there was one observation. Maybe
Yes.
Abdullah did it, right? Abdullah, did you
Yes,
recall?
yes.
Yes. What was the observation?
But now that I see this, now that I see this, I'm more convinced that this is better. I may have misunderstood before, but my observation was create a location class and have high tier or low tier as a variable inside the location, and then
Yeah.
yes.
And Mohammed, your observation?
Yes. Why don't we change the visibility of the audiobook delivery method and then make another method for the debug class.
Okay, oh, yeah. So let me comment
like
on
from
this.
a user perspective, I mean.
Yeah. So basically, I make this this get location one, this get delivery location one, private, and get another one which is the software one, right? That's what the idea is, right?
Yes, because you don't want to change the
Yeah.
characteristics.
So no, the problem is that it's still going to violate the Liskov substitution principle, because the idea is that if you are going to make it private, this means my understanding now is that basically you have no implementation there. It's just dummy.
Yes.
Right? Yeah. So but having a dummy method itself is on. It doesn't make sense from any good class design principles anyway. So probably that problem that will not resolve the problem, or will not resolve the issue we are facing with the Liskov substitution principle, because we still have a get delivery location method, which is basically either it's doing nothing, or it's actually it will go on and change the characteristics of the original one. Right?
Yes.
Yes. Right. So there are a lot of strength here, in a sense that now tomorrow if I have another online delivery mechanism, no problem, I'll just add it here. If I tomorrow have another offline delivery mechanism, I'll just add it here.
Yes.
Okay.
I see it now. I see it now. But
yeah,
I
absolutely.
just want to see what will happen for the situation.
Exactly. So any questions on this now, Liskov substitution principle?
Yes, Doctor, I have one question. Regarding breaking the Liskov principle, is it the only way to break it just to implement the function without code, or to implement it in a different, not in a different way, to change the characteristic of that function? Is that the only way to break it, or there is another way to break it?
So Ali, if I understand your question is that in this case, which was the original one where we were breaking the Liskov substitution principle, we will be breaking the Liskov substitution principle the moment this get delivery location, which we are inheriting and overriding, the code of this is different from what's the original idea behind the get delivery location. Okay.
No, yeah, I understand we can override it. We change some of the code, but the overall idea is to get the delivery location. I get that, and we are not breaking the principle here. But if we didn't write code, we make it empty, or we implement it, but we didn't. The function does not get us delivery location. It does something completely different. We are breaking in that case. Other than these two cases, can we break the principle?
Okay. Yes. I don't think so. It doesn't come to my mind at the moment. I don't think so. Because in an inheritance relationship, we basically are the maximum we are really doing are overriding, right?
Yes.
Yeah. So I don't think so.
Okay, thank you.
Yes, but this is very common, right? We tend to do this a lot of times, especially when we do overriding. We tend to make this mistake a lot. Okay, so I just want to, before I move to the next one, I just want to make sure that all of us are very comfortable about this point, that we are not saying that Liskov substitution principle, this is where usually the confusion is. We are not saying that Liskov substitution principle is telling us don't do polymorphism. That's not the idea. The idea is do the polymorphism in the right way and don't change the characteristics of the parent class method. Okay. So I think I believe I sense that everybody is understanding this one now.
Yes, it was easy. Not hard. concept.
Alhamdulillah, because I know over the years this is a bit trickier one. But I think I have a feeling now that you guys can relate to it and understand it, because usually we get confused between can I do overriding or not, or in other words, can I do polymorphism or not? So basically, you can do it, but do it in the right way. Now let's look at the another one, which is the interface segregation principle. It's not hard, by the way. This one is easy. All of them, I think, once you get a hang of it, they make a lot of sense. So interface segregation principle says that a client should not focus on or should not be forced to depend on methods they don't use. Again, we tend to do this a lot as well. That, and by, of course, by clients we mean classes that implement interfaces. So if I read this one, the classes that implement interfaces should not be forced to depend on methods they don't use. In other words, if I have an interface here, and in this interface, if I have 4 method signatures, and if I'm going to go on and implement this one, and I only need the 2, what will I have to do with the other 2 then? Yes, I do need these 2, but what about these 2 now? Can I ignore them?
You have to have empty implementation, unfortunately.
Exactly. Unfortunately, I have to have empty implementation or dummy implementations. And this interface segregation principle is actually telling us don't do it. All right. So in other words, interface shouldn't have too many functionalities in one go. You should focus on avoiding such situations where you have to just add dummy implementations, because that is counterproductive. Now, of course, interface segregation principle harms the code readability, of course, because you will be forced to, write dummy methods which are doing basically nothing. It will create confusion, of course, and of course, it even opens up vulnerabilities as well, in a sense that, at the moment it's dummy, tomorrow some other developer will come in. He may have an incorrect understanding of it. He may, just because the method is there, he will just go and change it and stuff like that. So you're opening up a lot of vulnerabilities there. So a well-designed application, you should avoid interface pollution. In other words, don't have fat interfaces. Don't have interfaces like this, where you have added all the stuff and then, only few are required by one class and another few are required by another class. Don't do that. Create smaller interfaces. And of course, it will give you more flexibility. Let's take our, book example again, and let's see if we can, understand this with the help of an example. So let's see, we have this online bookstore, and customers, we are creating the user interfaces now, for example, and the customers can interact with the content before they make a purchase. In other words, they can go on and review the content they want to purchase. They can search for secondhand copies of the books, or they can even listen to the audio samples before they make a purchase. So I said, okay, no problems. I'll create an interface called book action, and I will have these 3 methods in it: see reviews, search for the second-hand book, and listen to samples. And since I've created this interface, I will go on and, for the hardcover user interface, I will go on and implement it. And similarly, I'll go on and implement it for the audio book action. Now, am I violating the interface segregation principle in this case?
Yes.
And how?
For a hardcover book, you cannot listen to a sample.
Correct.
And similarly, for the audiobook, you cannot search for secondhand.
Exactly. So in other words, once I created these interfaces, I'm actually now forced to have them, and they're probably going to be dummy, which is again a violation of the interface segregation principle. So as we just noticed, the hard books don't listen, and the other one don't have the second-hand options and so on and so forth. It doesn't make sense in their own context. And because the way we created the interface, one fat one polluted one, we are now forced to go and implement them with the dummy implementations. So what we can do is we need to segregate it. So that means we need to go on and segregate our polluted interface, book action. What we can do is we can create sub interfaces, one called hardcover action, another one called audio action. And we can have the book action interface, which sees the review, which are because the C reviews are common across both formats of the items. While for the hardcover one, we have the search option, and for the audio one, we have the listen option. So with this new set of interfaces I can go on and now create classes for the hardcover, specifically only worrying about the searching option, while the audio one now can focus on the listening option. And both will still have available to them because we're going to implement the book action super interface like this. So the hardcover now will implement the hardcover action interface, and it will have the reviews available to it, and it will have the search secondhand option available to it, while the audio one will now go on and implement the audio action interface or sub interface. As a result, the C reviews are available to it, and also the listen samples are available to it. And I believe we all agree that we don't have that interface segregation principle violation anymore, correct?
Yes.
Correct. But Doctor, can I ask a question?
Yes, go ahead, please.
Now, C reviews are two separate signatures.
Yes.
So we make an action interface and then extend hardcover action with search secondhand, and extend audio action with listen sample. Because I don't know if C reviews, if it's called, how will it work using polymorphism in other places in the code? Because it's in two different places. They are essentially different. So, so is it an option or?
Okay, so let's look at it here now. So basically, Abdullah, what you're saying here is that this C review, right? In this structure now, because we have this parent interface in a sense, and these are the sub interfaces now, right? So as a result, when we're going to go the concrete class, this concrete class will have the C review and it will have the search second-hand book, while this one will have the C review and will have the listen sample options. So can you repeat the question, Abdullah?
Actually, I was asking so the hardcover action implements the book action. So,
are you talking about the first one or the second one, the new solution?
I was talking about the first one to convert it to the second one.
Okay,
sorry,
okay.
Yes, sorry.
Okay, okay. So let's focus on here. So how you can convert? What's your suggestion now?
No, I was talking about converting it to the same way of the second one, but I didn't know.
Okay, fair enough. So see, this is good, alhamdulillah. And I can see that you guys, based on your experience, you are able to foresee these issues, right? And this is actually really making me very happy and very confident here. But I believe now, by looking at these principles, it's now you're able to even relate that, why I'm doing this, right? And the reason I'm doing it is because, for example, I don't want to violate the Liskov substitution principle, or I don't want to violate the interface segregation principle, or open close principle, or the single responsibility principle, right? Everybody's comfortable with this one? Any questions on this?
Yeah.
All good, right?
Yeah.
Good, alhamdulillah. Not that difficult, correct?
Yes, I think it's that difficult. I think it's just like based on our experience, we know that.
Exactly. But now probably, the good thing is probably, A, because you know the reason for this, and B is you will be more careful as a designer now to make sure that, we, we don't violate these issues to come up with a
Right.
good design. Exactly. Now, I was about to say this at the end, but maybe I can make a comment here. Is that, if you notice, in all the solutions we are coming up with, we are coming up with more code base here, correct? We have more code here now. As compared to this, this will still compile, but this is a better solution, though it has more code base. So this is okay in a sense that this is a trade-off we are making here. That once I'm trying to follow these principles, it may result in me writing more classes or more code base, but it gives me a flexibility, and this is the idea behind coming up with a design which is more flexible, modular, so that it's easy to change, easy to buy, and once I make changes and flexibility is there, probably I will have to focus less on regression testing at the end and so on and so forth, right? So don't be confused that by following these principles, I'm adding more classes. So am I doing something wrong here? No, it's a trade-off we are doing here. Okay. Now, somehow for the first time in the semester, my two sections were slightly not synchronized on Sunday, because we had a bit of a discussion on Sunday in my first section about the open close, and it took us longer. So what I will do is I'll just to make sure that we both sections are synchronized, I'll stop here now for us now, right? And then on Thursday we will be inshallah looking at the last of the solid principles, which is the dependency inversion principle, and we'll do an activity as well, especially for the Liskov's one, just to make sure that everybody is comfortable with that, right? So I'll stop the recording. The floor is going to be open for questions, and inshallah let me take the attendance as well.